Hello my friends, and welcome back to the Wow Machine channel. On the island of Mindanao, Philippines, Dole's tropical gold pineapples begin their journey from lab to port through a tightly controlled process. In Stanfilco Biotic Laboratories, selected plant tissue is multiplied under sterile conditions, then transferred into coconut husk growing media to develop strong roots before planting in vast plantations. Propagation also uses crowns from mature pineapples, which are replanted or composted to enrich the soil. Harvesting is done with specialized boom harvesters, where workers hand-pick ripe fruit and load them onto conveyors that feed directly into trucks. These trucks deliver to nearby packing sheds, where pineapples undergo multiple washes, crown trimming, and manual grading. Skilled packers sort fruit according to weight, size, and market specifications, labeling and boxing them with on-site manufactured cartons. Finally, refrigerated trucks transport the packed fruit to Davao Port, where pineapples are stored in cool facilities before loading onto Dole's reefer ships. This seamless chain of biotechnology, mechanized harvesting, and cold logistics ensures the pineapples arrive in global markets at peak freshness, delivering the signature sweetness of the tropical gold variety. What happens when a humble onion leaves the field and enters one of the world's most advanced processing plants? At Gill's Onions in Oxnard, California, onion processing is carried out with precision, safety, and sustainability. Each truckload brings in more than 40,000 pounds of fresh onions, quickly moved into storage before entering the production line within 48 hours. Onions are peeled, topped, and tailed on conveyor systems, then disinfected with chlorine dioxide to guarantee food safety. From here, production is divided into multiple streams. Whole peeled onions are packed in sacks of 20 to 2,000 pounds. Others are sliced into rings or diced into precise sizes, weighed, sealed, metal detected, and prepared for shipment. Automated form-fill seal machines ensure 5-pound consumer packs are uniform and ready for distribution. Nothing goes to waste. Onion skins and peels are converted into animal feed, while onion juice is treated in anaerobic reactors to produce biomethane gas. This renewable energy covers up to 20% of the plant's daily power needs, turning byproducts into valuable resources. Mechanical pepper harvesting employs machines specifically designed to maximize yield while preserving fruit quality. Articulated platform harvesters move between rows, using headers equipped with rotating brushes or soft contact vibrators to detach ripe peppers without damaging the plants. Detached fruits are transferred onto removable conveyor belts leading to a primary separator, where leaves, stems, and debris are eliminated through calibrated vibration and airflow. Precise header calibration is essential. Forward speed, brush rotation, and cutting height must match the pepper variety, row spacing, and maturity stage. Integrated optical sensors, or multispectral cameras, detect ripeness by color and guide actuators that direct fruits to specific collection lines, reducing losses from premature harvesting. Onboard conditioning systems load the peppers into ventilated bins with anti-abrasive surfaces to avoid bruising during transport to grading facilities. Depending on the model, harvesting capacity ranges from 6 to 18 tons per hour under optimal conditions. For wet soils or sloped terrain, tracked traction modules and differential control maintain stability while minimizing soil compaction. Preventative maintenance includes daily inspection of brushes and belts, lubrication of gearboxes, and cleaning of air circuits to sustain separation efficiency. Complementary crop management practices, directed pruning, weed control, and scheduled irrigation enhance the effectiveness of mechanical harvesting. By integrating these technologies, Guaresi provides scalable solutions that improve productivity, reduce operating costs, and preserve post-harvest quality, supporting pepper producers across both fresh and processing markets. In ancient Egypt, the onion was revered as a symbol of eternity, its concentric rings representing the endless cycle of life. Today, onions remain essential, but their journey from field to table relies on advanced harvesting and processing technology. Mechanical harvesters lift the bulbs from the soil and line them up in rows, where they dry naturally for a day or two. Tractors then collect the onions and transfer them into baskets for storage at tightly controlled temperatures between 1 to 2 degrees Celsius. Upon arrival at the processing facility, onions first pass through cooling tunnels, where powerful fans reduce their temperature over 5 hours. Next, machines trim away tops and tails while scoring the skin for peeling. A specialized peeler uses air and water pressure to remove the outer layers, after which quality control workers inspect and trim imperfections. The onions are rinsed in cold ozonated water to eliminate bacteria before passing through a metal detector. From here, the production splits into slicing or dicing lines. Slicers cut precise rings from 1.5 to 25 millimeters thick, sealed into breathable plastic trays to preserve freshness. Diced onions, ranging from 3 to 25 millimeters, undergo a cold water treatment to extend shelf life before drying in packaging. Finally, automatic machines weigh and seal portions into plastic containers or zipper bags, smaller packs for consumers and jumbo bags for restaurants. Refrigerated, these onions stay fresh for weeks, providing cooks with a convenient, ready-to-use ingredient that saves time while sparing tears. Groundnut processing is a carefully engineered sequence designed to deliver clean, safe, and market-ready peanuts. At the groundnut processing plant of Agro Export, the process begins with raw groundnuts received from farms. These are first cleaned through vibratory sieves and destiners to remove soil, stones, and other impurities. Next, the nuts pass through grading machines that separate them by size and quality, ensuring consistency for further processing. Once grated, the ground nuts move to the shelling section where mechanical shellers crack the pods, releasing the kernels. These kernels are then separated from husks using aspiration systems and passed through gravity separators for additional refinement. Workers detect and remove discolored or damaged kernels, maintaining strict quality standards. Finally, the processed ground nuts are packaged according to client requirements, whether for edible use, oil extraction, or export employs vacuum packaging technology. This method protects the peanuts from moisture, oxidation, and microbial growth, making them ideal for export. The full automatic Sachima and peanut candy packing line by Landpack Packaging Machinery represents a highly efficient solution for modern food production. Designed to handle delicate products like traditional Sachima and peanut candy, the system integrates feeding, wrapping, sealing, and cutting into a streamlined process. Using globally recognized components, the line ensures stability, precision, and long-term reliability. Horizontal and vertical flow pack machines, combined with intelligent feeding systems, allow consistent performance and reduced manual labor. With adjustable speed controls and advanced sealing technology, the packaging process maintains product freshness and presentation quality. The system is versatile, suitable not only for confectionery but also for grains, powders, liquids, hardware, plastics, chemicals, and daily use items. Its modular design allows quick changeovers, easy cleaning, and minimal downtime. By delivering accurate, hygienic, and high-speed packaging, the Landpack line enables producers to meet growing market demands while optimizing productivity and cost efficiency. On the lush Hamakua coast of Hawaii, macadamia nuts follow a remarkable journey from orchard to table. Introduced from Australia in the 1880s, these trees take about 7 years to reach full production, making each harvest truly valuable. Blossoms known as racemas develop into green nuts, which mature inside a tough husk and rock-hard shell. Once ripe, the nuts naturally fall to the ground, signaling harvest time. At the processing facility, dehusking machines strip away the outer layer before the nuts are dried in massive stadium dryers to reduce moisture. Precision cracking machines then apply over 300 pounds of force to release the kernels, which are separated from shell fragments by rotating screens and high-speed optical sorters. Finally, the kernels are roasted, inspected, and vacuum-packed, ensuring freshness before being transformed into Hawaii's signature macadamia nut treats. The Nut Roaster Pisto Mega is a versatile machine engineered for roasting a wide range of nuts and seeds, delivering consistent quality with a capacity of 25 kilograms per batch. Its innovative design combines efficiency, precision, and hygiene. The system employs electrically heated air with hot air recycling, ensuring optimal energy use while maintaining uniform roasting. A built-in product stirring mechanism guarantees even heat distribution across the entire batch, while the adjustable speed and temperature controls allow operators to fine-tune the roasting process to suit specific products, such as salted peanuts or seasoned seeds. Designed for easy cleaning and maintenance, the Pisto Mega offers quick installation and smooth integration into any production facility, making it a reliable choice for industrial-scale roasting. Step inside the Bell and Evans breeder farm, where precision and animal welfare go hand in hand. Each house holds around 14,000 hens and roosters, carefully managed with automated feeding, watering, and ventilation systems. Roosters and hens receive separate diets tailored to their needs, ensuring healthy egg production. The houses feature natural light, curtain ventilation, and barn scrapers that remove manure 5 times a day, improving air quality and reducing pests. Eggs roll from nests onto conveyor belts, graded, packed point down, and cooled before being transported to the hatchery in Fredericksburg. Apollo Generation 2 chicken harvester represents a new standard in poultry handling technology. Designed to improve efficiency and animal welfare, it allows birds to be harvested with minimal stress while reducing labor demands. The system features independent catching belts that gently collect chickens, ensuring better load quality and higher productivity. Only 2 operators are required, and they never need to physically touch the birds, which greatly improves biosecurity and worker safety. Containers remain elevated throughout the process, never coming into contact with manure, reducing contamination risks. With a short setup time and easy cleaning design, the harvester is engineered for consistent performance and quick turnaround between operations. By combining humane handling, robust hygiene, and operational efficiency, the Apollo Generation 2 delivers both economic and welfare benefits, setting a benchmark for modern poultry farming practices. The craft of handmade tile production blends sculpture, precision, and tradition. At Tiles of Stowe, the process begins with original clay carvings, carefully sculpted to form unique designs. From these, plaster molds are created, serving as the foundation for consistent reproduction while preserving the individuality of handcraft. Clay is pressed into each mold, compacted to capture fine details, and then carefully removed. Once shaped, the tiles enter the drying stage, a process that can last up to a week depending on humidity, airflow, and ambient temperature. This natural drying allows the clay to stabilize, reducing the risk of warping during firing. When fully dried, each tile is fetled, meaning edges and surfaces are smoothed to remove imperfections before firing. The first firing, known as biscuit firing, takes place at around 1020 degrees C. This transforms the raw clay into a hardened, porous ceramic body. The tiles are then dipped into glaze, a glassy coating that provides both durability and aesthetic finish, before undergoing a second, higher temperature firing. The two-stage firing process not only ensures structural integrity, but also enhances the brilliance and depth of the glaze. Each piece emerges as a functional work of art, suitable for architectural applications, yet retaining the tactile quality of sculpture. Handmade tile production demands patience and precision, with every stage, from carving to firing, requiring time and care. The final results, such as tiles crafted for historic restorations or sacred spaces, carry both artistic and cultural significance. These works embody craftsmanship that transforms clay into enduring decorative art. Egyptian cement tiles represent a blend of tradition, craftsmanship, and durability, offering both aesthetic and structural value in architectural design. Unlike fired ceramic tiles, cement tiles are produced through a hydraulic pressing process where layers of colored cement, marble powder, and fine sand are carefully poured into patterned molds. The pigment layer, typically 3 to 4 millimeters thick, allows for vibrant and long-lasting designs, ranging from geometric motifs to floral and arabesque patterns that reflect Egypt's cultural heritage. The manufacturing process involves filling the mold with the colored mixture, followed by a backing layer of cement and sand for strength. The tile is then subjected to high-pressure hydraulic pressing, which compacts the layers into a dense, durable product. After pressing, tiles are cured in water for several days to achieve proper hardness and stability. Unlike glazed tiles, cement tiles gain their finish from polishing, which enhances their matte yet elegant surface. Known for their longevity, Egyptian cement tiles can withstand heavy foot traffic, making them suitable for both residential and commercial applications. Their artisanal production ensures each piece carries unique character, bridging centuries-old techniques with contemporary architectural use. John Lobb Shoemakers represents the pinnacle of English craftsmanship, where tradition and precision meet. Each pair begins with detailed measurements from which a wooden last is carefully carved to capture the exact shape of the client's feet. Skilled artisans then cut, stitch, and mold the finest leathers entirely by hand, applying time-honored techniques such as hand-welting and meticulous polishing. The process, often taking weeks, ensures shoes of remarkable comfort, durability, and elegance. More than footwear, each creation is a work of art, a legacy of timeless style carried forward through generations of shoemaking mastery. Colloidal emulsion explosives are a class of industrial blasting agents used in controlled surface and underground blasting operations. Visually resembling a pale, sludge-like mixture, these modern emulsion systems combine oxidizer phases and fuel phases in a dispersed matrix to deliver consistent detonation characteristics under engineered conditions. Their formulation is designed to be insensitive to casual handling, yet reliably detonable when used within licensed blasting systems and with approved initiation devices. Applications include mining, quarrying, and large-scale civil excavation where predictable energy release and reduced shock transmission are required. Compared with older dynamite-type products, emulsion systems often offer improved thermal stability and resistance to water ingress, making them suitable for challenging site environments. Regulation and oversight are central to their safe use. Licensing of manufacturers and transporters, strict storage protocols, chain of custody documentation, and trained, certified blasters are mandatory in most jurisdictions. Environmental considerations, such as minimizing fly rock, controlling vibration, and managing post-blast residues, guide operational planning and monitoring. Emergency response plans, blast monitoring, and community notification procedures form part of responsible project management whenever industrial explosives are deployed.